All right, guys, let's get started. So yesterday, um, since the beginning of this week, we are focusing on the .NET part. On day one, we looked at microprocessors and digital electronics very closely. On day two, we looked at the C# programming language. So C# is a high level programming language, and the statements in this language, they are going to look a little bit like English language itself. The reason we write program in languages like C# is because it is easier to read and understand, but then they need to be translated and converted into a machine language, which is a series of bits and bytes. And then in between this machine code and C# program that we have, there lies multiple layers, such as the hardware layer, the operating system layer, and um, then C# provides that translation between from C# to an intermediate language, which is independent of the platform, which is standard. And then it gets converted to an executable for the operating system and the platform that you are running on. Then we saw multiple data types or two types of data types. So one is the value type. From our discussion on microprocessors, value types is something that goes and sits on the stack. Each So each value type is going to have its own memory location inside the stack. And when you pass it around to different function assigned to different variable, a different copy is created every time. The reference types, they are a little different. The reference itself sits on the stack, but then the storage of these types, it happens on the data segment. So when you pass a reference of one variable to another, it is the same memory location that you are referring to, and then changes made by one function or one reference is affected using um, gets affected even if the other reference is used for modifying those values. Then we looked at data types and we established the fact that data types are two things. One is how they look in the memory, the storage, and second is what operations they support. So an integer could be positive or negative, and it's a 32-bit field. So depending on what type of integer you're declaring, integer or unsigned integer, the signed bit is going to have different value and the range is going to differ. The operations available on integer is going to stay the same. Character does not have any signed bit, and then it is 8-bit field. These 8 bits, they are also series of ones and zeros. And then to convert these ones and zeros into English characters, there is a standard called ASCII, and ASCII defines what each code means. So capital A is 65 in decimal, 41 in hexadecimal, and small a is 97 and 61. If you convert these to binary just by replacing their equivalent with 4-digit binary number, you're going to get the hexadecimal. And we saw that only bit number, I would call it bit number 6. Bit number 6 is different for small and capital letters. And then if you ignore this bit using the XNOR gate, you are also always you're going to get a 0 result if they are equal. So we saw a comparison of this, and then we also compare it to advanced microprocessor instruction like compare is going to compare CMP is going to compare case sensitive comparison of these bits, and CMPI is compare insensitive, going to compare ignore bit number 6 here. All right, and then this is also going to reflect in your C# code. Right. Then we saw a concept of abstract data type when the data types that are available from the programming language, from the programming platform, when they are not enough, you will have to come up with custom data types, and then you'll have to bundle them together. And that bundling is also subject to the two rules of data types. They are supposed to have a structure in the memory, and they're supposed to have a bunch of operations. Then we picked up an English paragraph, which was for a bank account, and then we assigned different English grammar rules to it. And using these rules, we were able to create a class for the bank account. Verbs become the member um, functions or methods. Constraints, they become conditions inside the functions that we're going to define. The relation is going to define if they are going to be a member or they are going to be another class. And then adjectives, they become generally the properties. All right. So we saw another concept, once again mapping to the English language, that abstract nouns are abstract classes, and you cannot create an object of an abstract class because it is like going to the market and asking for fruit. Unless you specify the type, unless you use a proper noun, you're going to have very hard luck buying a fruit. You will have to specifically tell them that you want apples or mangoes or oranges. Okay, so this was C# so far. Then we saw a couple of tools like ILSpy. ILSpy, ILSpy is a disassembler. What it does is it takes an assembly, and this assembly is a DLL file, broadly speaking. You can add these assembly by dragging and dropping, or you can open up these assemblies through your folder location or from a special place called Global Assembly Cache. We're going to talk about this probably in the future. When you open when you open this DLL file, there is special information that you are going to see on this side of the screen, right? It is a summary of the assembly. There are files that I'm going to show you, which contributes to this value getting inserted here. When we expand this and look at these assemblies in more detail, you're going to find multiple metadata and other information, and you're going to see namespaces that you have defined inside the code. So these parentheses here indicate namespace. In the namespace, we're going to have multiple classes. We created this class called bank account. So bank account is appearing over here. I was trying something yesterday, so um, don't worry about this syntax. And then inside the program, I had the main function. So the main function, so the function here are going to look like this. Small signs here, they are going to indicate if they're a constructor or they're a private static member, and it's going to provide extra information. This tool comes in extremely handy when you want to understand the relationship between the intermediate language code and the C# code. So the first step of any of the C# compiler is that it is going to take C# statements, something like this, and it is going to convert it into an intermediate language. This is the same code that CLR or C# compiler is going to generate when we are doing programming in any of the .NET platform language. If it is VB.NET, even then it is going to look like this. If it is C#.NET, it is going to look like this. Right? So we saw this, and for today, we're going to talk about a few other data types that we did not cover yesterday. Okay, so before that, I want to talk about the two concepts that we are discussing like parallelly, and we are doing a lot of back and forth between it. And I think it is necessary that we make that distinction like right now. So we have there is .NET and there is C#. .NET is okay. The .NET is a framework. Now, if I have to draw a diagram for, to help you understand this better, we have a hardware, and then this hardware is the processors that we saw, like 8086. .NET is not going to run on 8086, but then this is the hardware layer, 386 or whatever Pentium or i3, i5 processor, i7 processors that you have. This is where the hardware sits. On top of the hardware, we have another layer of the operating system. The operating system is for .NET framework is going to be Windows, but then with .NET Core, right? So there are two .NET frameworks. One is .NET FX and the second is .NET Core. So .NET Core is cross-platform and it supports Linux and Mac as well. So there is this orange layer is the operating system layer, and on top of this orange layer, there is another layer, which is the .NET framework. Now, the reason we need this framework is because when you write, okay, computer programs, all they do is they leverage the processor and the input and the output device eventually, and they try to interact with, they try to perform operations on this hardware and provide some form of result to the end user. Every time your hardware changes, you will have to make changes to your code, and you don't want that. In fact, you would want to take away a lot of code from you, and then operating system is one such spot which is going to provide you these services. So if you have, say, file management will be done by the operating system for you, right? If you have any keyboard interaction or IO device interaction, the operating system is going to provide you with a lot of utilities, and these utilities will then interact with those devices that are connected to your computer, such as a keyboard or probably say a monitor, or if you want to download something from the internet, right? Uh, the Ethernet card is going to do that activity. But as a programmer, you don't want to write these programs yourself every time. So then this layer of operating system here, it controls the hardware and it takes away all those tasks of connecting to the internet, interacting with IO devices, or persisting your data on the hard drive. So this is generally the functionality of an operating system. Now, even these operating systems can be different. Like Windows has multiple versions starting from say 93, Windows 3, Windows 98, 2000 XP, and then all the way up to the Windows 10 version that I am using right now. So this operating system, they are going to have different version themselves. And then they're all the same platform, but then when you jump cross platform, you're going to have Linux and Mac joining the team as well. And they are going to have their own versions and framework. So there are multiple versions and frameworks of operating system, and the program that you are writing, you don't want to take care of the operating system that it is running on. And that's where frameworks like .NET come in picture. Now, .NET is going to provide you a consistent mechanism. .NET is going to say that, hey, depending on the operating system that you are running on, I'm going to provide you an OS specific framework. And that is .NET. So for each operating system, they are going to have an implementation of .NET. On top of this, we are going to write our custom application. So the code that we were writing since yesterday is something that sits here. And for the most part, our focus during the rest of the course is going to be this blue layer here where we are writing our code. Make sense? All right. So let's jump to C#. Now .NET is a framework. C# is a programming language. What happened to all these mouse buttons? C# is a programming language. Now, a programming language is going to give you a bunch of syntax. All right, it is going to give you the structure of where you are going to create your classes, your interfaces, and the functions that you have. And there are multiple other programming paradigms or options available in C# language, using which you are going to create those English-like sentences where you're going to say that on the console, I'm going to do a write line and I'm going to print the hello world message. Make sense? So .NET has multiple versions. It started, I guess, um, back in 2002 with version 1.0, and then there was version 2.0, then there was version 3.0, 3.5, then I think there was 4, and then 4.5, and then now starting I think around version 3.5, they came up with a newer version. So up until this point, this was .NET Framework, and then starting version 3 or 4, they came up with a new framework, which was .NET Core. And this is where Microsoft went open source and Microsoft went cross-platform. So this is where with Core, they started supporting Windows, Linux, and the Mac operating system. .NET Core was in probably 2014 timeframe, and now starting .NET 5, Microsoft is merging the .NET framework, which is in version 4.8, version 5, and they're merging it with .NET Core. So .NET Core had version 1, 2, 3, and then Starting this, they have removed the word framework and core itself, and now it is just .NET. Okay, so this is the history of .NET. I think version 6 is in progress, and um, they're kind of merging what each platform supported. If you want to create solutions that are very specific to Windows and they are using like Windows native operating system features, you will have to stick to .NET FX or .NET Framework. If you want to create something cross-platform that you would want to run on any device, right, you will have to stick to core. And by any device, I mean even the Android operating system or the iOS operating system. So using .NET Core, you can create applications for Android and iOS as well because it is cross-platform. You can also create applications for Xbox and Windows phones. So this is framework, and the framework kind of sits on top of the operating system. There are multiple bits to this framework as well. Uh, I would like to talk about at least two. One is the base class library, and the second is the CLR itself. So the options that we were seeing here inside ILSpy, they talk about CLR, and CLR is the common language runtime. Because I use the word runtime, I'm going to tell you two more things about it. So there are two parts. One is CLR, and the second is the SDK. CLR stands for Common Language Runtime, and SDK is Software Development Kit. Now, with any other three-letter acronym that we have seen in the past, we are going to try to read it from the past. So a runtime of language that is common across multiple platforms. Okay, so there is a framework which is a runtime, and runtimes, they help you run your code on a specific operating system, and it is going to be common across all the languages. So what it means is that whether you are running VB or whether you are running C# or you are running F#, right? The runtime is going to be same. And then because you want to keep the runtime same, you need support for this intermediate language. So no matter what kind of language you are running on, the IL code, the intermediate language code, is going to look the same for all the platforms or all the supported languages. SDK is the software development kit. So a kit for development of software. The way we develop software is we write programs like these here, C# programs. All right, and that's how we develop software. And when you want to develop the software, you will require, say, a compiler. So a compiler is going to take your C# code and it is going to run it through multiple phases. It is going to identify what is a function, what is an interface, what is a class, how are they connected, and it is going to spit out those IL code that we were looking at. And these IL codes, they will eventually get converted to the executable of whatever platform you are on. Once you have these files available, all you will require is runtime. So only developers require this, but then anybody else who is going to execute your application, they will require a runtime before they can make use of your executable files. With that said, on our dev machine, we are going to have .NET SDK. But then in our, say, test machine or production machine, we can get by with having CLR. Now, this distinction is going to become extremely important when we are in week number 8, 9, and we are talking about Docker. There are two types of Docker images that we are going to get. One is going to be SDK. Using SDK, we are going to transfer multiple C# file, the C# project file, and then we are going to run the compile command, create an exe. And then once we have that exe, we're going to create a CLR image. And on that CLR image, we are only going to copy the exes and DLLs. Okay, so CLR is for running the code, SDK is for developing the code. So let's move on and let's talk about a C# program. I'm going to jump back to Visual Studio. Okay, while that is loading, let me show you where you can download those two frameworks. So You can go to .NET.microsoft.com, and then when you see free and cross-platform open source, it is the .NET Core that you are going to download. So you can download it from here, uh, download an executable, run it, and you're going to have the .NET Core framework on your machine. For .NET Framework, you can go to specific .NET Framework folder, and then it is specifically going to say that it is the .NET framework. And then there are different versions starting 3.5. There are other out of support versions as well. You can go and look at the frameworks that are available, but the current version that is in support starts from 3.5 all the way up to 4.8. And then this is also going to tell you when these products go out of support. So .NET Framework 3.5 is going to be around till 2028. That's okay. I was like, that's a long time, man. And I mean, you can read the dates for other versions as well. So this is .NET Framework. This is how you download that framework. I was looking for a version of SDK and runtime as well. So this is the runtime. If you download this, this is what you need on production machine. But then developer pack is something that is going to download the SDK for you. I think it's going to be the same for .NET Core as well. That is going to give you multiple options. All right, once again, this is .NET Core SDK, and this is .NET Core runtime. Close out of these two. And we are back in Visual Studio. So I'm going to copy some code from the internet. I'm going to show you. All right, let me just give you a brief walkthrough of this tool itself. So this is Visual Studio 2019, and um, there are multiple options. File menu, there are toolboxes, there are server tools using which you can connect to other computer like a database server, the MS SQL server that we saw in the last sessions. In the first session, we talked about Git and Git repositories. So you can connect to multiple Git repository. You can clone your repositories using this option. If you don't see this option, probably you will have to activate it from the update panel, and this will be available as part of default installation. You will have to check special boxes to get this working. A solution is where our code is going to be listed in different project and file format. You can organize them into different folders. Team Explorer is once again a spot where you can choose the DevOps feature. You can check in, check out, and compare the different versions that are available. Then class view is a different view of your solution where you can see multiple classes and how they are organized. To create a new project, you'll have to go click on File, New Project. My general strategy is to start with a blank solution. So let's go ahead and do that. A blank solution is going to give you just a solution, and then I'm going to say demo, full stack developer demo, and I'm going to hit the create button. Now all it does is it creates an empty solution file, which is going to be available over here. Now I don't know if I can open it here by double clicking, but I definitely can open it in Notepad. So I'm going to right click, I'm going to fire up Notepad and pull the file into this. And this is a default structure of a solution file. It is, I think it is a Microsoft proprietary file syntax. It is not a standard XML or a YAML file. It is Microsoft proprietary. You can read through this, but then as we make addition of different projects, it is going to give you different. It is going to add more things to that particular file. So let's go ahead and add a console application. A console application is something that is going to run in the command prompt. There are multiple options that you can choose from: C#, C++, F#, Python, and multiple other languages. For this course, we're going to stick to the C# language. And as I said, you have option of developing .NET code for multiple platforms. I have selected Windows here, and because I have Windows, I have many options available. But then if you switch to, say, a Linux operating system, your options, notice this, that the scroll bar size has increased, and it is definitely going to be .NET Core. And then the project that type that you want to create is also available over here. Because we are creating a console application, I'm going to select console, and then you're only left with one template. Right, so C# for Linux on of the console type is going to display this. Depending on the type that you select, you're going to see multiple options. We are going to see ASP.NET Core Web APIs in the next week. But then for now, let's just jump back to console and hit C#. And I'm going to, I don't know, let me select all platform. And then when you select all platform, you're going to see two options. One is .NET Framework, and the second is .NET Console. Now the C# code for .NET Framework and .NET Core, it is going to look exactly the same. And then notice one more thing, that because it is Visual Studio 2019, it is not explicitly mentioning like it is mentioning .NET Framework. It used to mention .NET Core as well some time back. But then now that they are merging the naming convention, they're not going to mention that. So unless you specifically select .NET Framework, you are not doing .NET Framework work. If you don't see explicitly mentioned .NET Framework, you are probably doing core work. So we're going to select the .NET Framework for today and hit the next button, and notice that there's an option of selecting the .NET Framework for which you want to do the development work. Now, because I'm seeing 2.0, 3.0, 3.5, all it means is I have downloaded the SDK for these particular frameworks. Unless you download an SDK, you are not going to see these options. Right? So it is because of the SDK that I am seeing so many frameworks. I have all those SDKs available from my default installation. This is where you're going to give the project name. Because our solution name is FSD Demo, Full Stack Developer Demo, you would want to have some form of connection between the solution name and the project name itself. So I'm going to once again call it FSD Demo and then dot. I have a standard of naming things. Because it's the console solution, I'm going to call it console app. When we create WPF applications, I'm going to name it differently, but then I generally carry the solution name back to uh, the project name as well. With this, if I hit the create button, all right, it is going to pick up a template available with the solution, and it is going to provide this default code. There are a bunch of using statements that have been added, and a using statement essentially is referring to one of these assemblies. So system, everything that is available inside the system is included in our solution. Unless we start using it, they're going to appear gray. This is one of the Visual Studio features. And as we start using these assemblies, they're going to get in the darker colors. And now let's go ahead and try reloading this solution file. So that did not change anything because we did not save our solution yet. So when you add solution to a project to a solution, you will have to specifically go and click on save all. And then that's when the project is going to get added to the solution. So now once again, let's bring this up. I'm going to drag and drop it over here and notice that something has changed. So let's just maximize this and notice that it has added these 4 lines for sure, this global section, and somewhere there will be a mention of the project that got added to it. So notice that the project that we added is fsddemo.console app, and it is going to add those project references in this particular file over here. And then as you make multiple changes to the solution, this file is going to get updated. It'll be nice to keep an eye on this file if you want to understand what is, how these solutions are organized. You would probably want to go back and study what pre-solution is, what post-solution is, because this is going to give you some insight as to how to interact with Visual Studio and how to perform a certain operations during different phases of your project. All right. I'm going to show you the assembly info file. And I hope you have seen this somewhere today, earlier today. So if I bring back, let's just go ahead and build the solution. I'm going to hit Control Shift and B. It is going to generate this exe. I'm going to copy this path and then launch it. And then it is generating an exe file. Now I will not be able to pull up and pull an exe file into ILSpy, but let's go ahead and give it a try. Okay, so the exe is here, and it is displaying all the information from our code. So our main function currently is empty. But if I click on the app itself, somewhere I had seen the assembly information. Okay, let me switch to C#. And this assembly file here is used to define the assembly level information. And this is where all that information is coming from. If for any reason you want to create a different version of this assembly, you will have to come and modify this number. And this is going to be one of the activities that we are going to perform during the DevOps part of our solution. As you are building a newer application, you would want to have a strategy about updating this application version. Right, so that is the assembly file for you. In the references, you're going to see system.core, system data, and a bunch of other DLL files that are essential for running our application. If I go to program once again and type console.writeLine. All right, notice the first line, it kind of turned dark. Right, and this is the using statement. So console is actually present in the system assembly. If I hit F12 or right click on this and say go to definition, it is going to decompile this DLL file, right? And then I told you about in the morning a special location called the GAC, right? This is all right. So GAC is a folder inside Windows Assembly, and it is called Global Assembly Cache. So when .NET Framework gets installed on your computer, it is going to create all these folders depending on what version you are picking up. And most of the DLLs that we are going to use, they are going to be organized and arranged over here. What essentially has happened when we pressed F12 or said that go to definition, Visual Studio has gone to this folder. It picked up this DLL file and it extracted out the class information and the function information or the member information of the console class in and represented it in the C# file like sentence. And the way to know how it is done, it is going to give a nice friendly message over here that it has been decompiled from this location. So this actually indicates that it is the MS Code library and the version is 4.0 culture and the public key token. This public key token is essential if you want to have your DLLs deployed to the global assembly cache. Now, once again, because this is very specific to the Windows operating system, GAC is available only for .NET Framework. It is not available for .NET Core libraries. With .NET Core, you will have to use other tricks to have signatures and culture information presented like this. So this is the console class. 90% of the time, we are going to limit ourselves to write line and read line. I don't know if I saw even a read line over here. Right. So these are some of the functions that we're going to use, and look at this definition of write line. So in C# or in object-oriented programming, there's a concept called polymorphism. With polymorphism, you can have the same name of the function, but different parameters. And notice that all these functions, they have the same return type of void. So function signature always starts with the function name and it is towards the right, but then never on the left side of it. Okay, so we are allowed to modify only the parameters that it can accept, and there are multiple interesting parameters. So we have seen these basic primitive native data types. There is something called as, okay, so this is a different assembly. I was hoping for at least one more parameter, which is variable number of arguments. All right, so probably we're going to see that later, but um, this is how you go to GAC assemblies and look at the implementations that are available. You can also hit F12 or go to definition of these functions. If I hit F12, it has picked up the right implementation of string and value. Now, notice this, the dots here. It is the solution documentation, and I think the way to generate that is using the inline documentation feature. So double slashes, they're going to comment out a code, and triple slashes, they're going to provide project level documentation. So if I hit the third slash, notice that it is generating a summary, main class for our application. And then this thing is going to become the default documentation that comes with our solution. As we do more and more programming, we are going to see different, we're going to read through these different sections. So because it was mentioned in the XML tag, when we look at these, okay, so from metadata is the generation from the GAC, but then those XML tags, they're going to become the headings here, and anything that we put is going to appear in the form of these comment section, right? So this is how you generate the documentation. Okay, let's now go ahead and compare. Okay, so I already showed you the C#, the solution file. Let's go ahead and take a look at this CSproj file as well. Let me bring up the folder structure. So the solution file sits here. When we add a project, it's going to add a folder to the solution. When you go inside, you're going to see multiple file. One such file, one of the important file is the CSproj file. So let's go ahead and open this CSproj file into inside Notepad. All right, and this is once again another proprietary XML format where you're going to have project information. Every time you add a file to your solution, it is going to go ahead, it is going to make an entry in this particular item group section. There are multiple item group section. The C# files, they get added here, and the assembly references that you add, they are going to get represented here. Now, when you see a direct include statement, it indicates that these things, they're going to come from the global assembly cache. Also notice this property section here, it is saying that it is the release version and it is built for any CPU, right? If you want to limit your application to run only on the 64-bit operating system, you can change that option from over here and you can select the processors that are available, right? You can add the platforms like x64 and you can hit OK. And if you make this change, I'm going to ignore. But then if you make this change, it's going to come and modify these values over here. Right. So this is the structure of a CSproj file. It is a proprietary XML format. Let's go ahead and fire up a new Visual Studio. And this time we're going to build a .NET Core project. So once again, I'm going to go to File, New Project. I'm going to leave all these options as is, but then I'm going to pick up the console application. It is saying .NET Core over here. I'm going to hit next and notice that these options have changed a little. Okay. All right. So last time I showed you that I start with a blank solution, but there is an alternative to that as well. Let's just say FSD demo of core. And then I'm going to say .console app because I'm creating a console application. And then over here, I'm going to come and delete this part. So if you want to have a solution created alongside the project along at the same time, but then want to have different name, that is allowed. And you can choose where you would want to put this particular project. This option is going to come in handy once again when we are going to do Docker in the coming weeks. But I'm going to leave it as is, and I'm going to hit the next button. And then there's an option for choosing framework. Notice that we are not seeing .NET Framework 2.0, 3.0, 4.8. We are seeing .NET Core and starting .NET version 5, as we discussed earlier. They are not calling it .NET Core anymore. They're calling .NET. And .NET version 5, it is the current and latest version. So let's go ahead and pick that. Hit the create button. And it is going to generate a different C# program. The last time around, we saw at least 4 or 5 using statements, and then there was no console.writeline hello world written anywhere. The default template for a .NET Core project is this, that it brings very limited number of assemblies that you require. And then notice that they are calling it dependencies. In the framework version, they were calling it references, and they're organized a little differently. So there are better categories that tell you that assemblies are coming from a different location. Now we are, as we drill down into these structures, you're going to see that, okay, I don't know why I'm seeing Visual Basic here, but these are the assemblies that are eventually going to get used as we are working on the application. If I compare it with .NET Framework, notice that they had references and assemblies were their assemblies looked a little different. The folder structure itself looked a little different. There was something called as properties and assembly info. Now, when we come here, we don't see any of that. Let's try and double click. So I'm back in the .NET Framework project. When I double click on this, nothing actually happens. Let's go ahead and try that for a .NET Framework project, a .NET Core project. And when I double click on it, it opens up a different file. All right. So the project structure, the csproj file of .NET, I should not call it .NET Core, of .NET looks a little different, and it is very accommodating. It is extremely easy to read, and all it is saying that the output is going to be an executable, and the framework that we are supporting is target framework is .NET 5.0. Now this little name here is something called as moniker. A moniker is a short for the framework version that you are using. You have to compare this with the .NET framework. There is a tag called .NET Framework version, and the version here was version 4.8. I think one of the difference between .NET Framework and .NET Core is that at one time you can only build code for one particular framework. So once you choose 4.8, you are locked to 4.8. But .NET Framework is .NET Core is a little more accommodating. And if I want to create something for Framework 3.1, I can mention 3.1 over here. For now, I'm going to delete this and I'm going to show you something. When we right click on this, hit the build button, and it is going to work just fine. I was hoping that it's going to give me a path where it has saved this, but let's go ahead and open the file explorer. And if I go to the bin folder, the debug folder, I'm going to see .NET 5.0. Let's see what's inside this. Right, there's a bunch of DLLs and exe. This is different compared to what we saw in the framework. In the framework, we did not have any DLL. There was just one exe and one PDB file, I guess, and there was another file. Let's go ahead and bring that up. So in bin debug, we had exe config, and a PDB file, right? But inside .NET Core, it is definitely going to generate a DLL file. Okay. Because .NET Core supports multiple framework, and if you want to build for another framework, you will have to figure out the moniker for the framework that you want to support. And with this one statement, now it has started supporting .NET 5 and .NET Core 3.1. If I come here, now I rebuild the solution. Okay, it is saying that this name is not correct. So I'm going to go and search for the correct moniker. Right. Somebody needs to go mute. All right. So the moniker name, if you accidentally forget or mistake it for something, you will have to come to one such page and figure out what is the version that you are picking up. So for .NET 5.0, you can have all this, and then probably I'll have to say NetCore App 3.1. And now if I come and type NetCore App 3.1, hit the save button, hopefully I'll get through this time. Okay. So there are some assembly conflicts that are happening. Let me figure this out. My framework. I was hoping that this is going to get me through. All right, but then it is possible. It is possible to do parallel build of .NET 5. Okay, I think I know why it is happening. It is probably because of this SDK. So this SDK does funny things. .NET 5, it started supporting Windows as it had better support for Windows-based application. And when you type this, or I think there are 2-3 versions of SDK. Okay, I'm not sure, but I think if I remove this and create a 3.1 project, I'll be able to provide multiple .NET Core frameworks over here, and that will take care of, that will go ahead and, not this folder. Okay, so when we do that, we are going to see parallel folder alongside this. So .NET 5 is going to have .NET 5 specific implementation, and .NET 3 and 2 and other names that we have mentioned in the CS project file. They are all going to have their own folders. And using this, we can create solution for multiple .NET Core or .NET frameworks. Okay, so that was one topic that I wanted to cover today. All right. Let's look at the main method more closely. Now, from this point onwards, I don't think it will really matter if we are doing .NET Core programming or .NET programming, because most of the differences that are there, we have already covered. So it wouldn't really matter what version we are talking about now. But let's go ahead and analyze this program more closely. There's a class that we have declared, we have called it program, and then the main function is defined as static. Okay, now static function or static keyword here has a special meaning. What it means is a class is a template. So if I go back to our whiteboard diagram from yesterday, the data type discussion that we did is data types are going to have two things. One is what they look like in memory and what operations they support. When we lay out this structure, all we are saying that this is what it is going to look like. But when you want to use it, you will have to declare an object of this thing. So what an object does is from our discussion of microprocessor, if I can draw the RAM again. So the RAM itself is going to look like this, and we're going to have different segments, one for code, one for data, and one for stack. Everything in between after data is the extra segment. The code itself is going to sit here. The code is going to have those cryptic instructions that are going to correspond to initializing variables, initializing different memory locations. When we declare a variable called integer, when we declare variables like integer I, this statement is going to get translated into getting some memory from the stack because it's a value type, number one, and it is declared uh, inside the block of code. But then you wouldn't always want to have uh, uh, instances saved to stack. And if I put a static keyword over here, that is going to change its location. Now, a static variable has a different life cycle. It is not limited to the block, and static variables are declared in the data segment. So with the static keyword, it is going to come and start sitting in the data segment. This is going to be the location for the variable I with the static keyword. Defining the memory structure of the variable itself is going to give you that template, right? But it is not going to give you any memory space until you see an instruction like this, right? What I'm essentially, so this declaration is going to get the memory for the integer variable that we have. But in scenarios where you don't want to give this memory, when you don't want to create these variables, you go ahead and you modify it with static, and that way you don't have to create that instance. So the static keyword removes the requirement of writing such a statement. If I can explain that better, let me go ahead and create a new class, and I'm going to call it, say, bank account. And only going to have one parameter here, which is I'm going to call it public property integer, say account number, or I'm going to say ID. I'm going to delete the rest of these things. Now, if I come to this function and if I say, if I want to access the ID field, even if it is public, I cannot see it over here, right? Because bank account is a template. It is saying that, hey, create a member, create an abstract data type with this particular memory structure. The only way to access this, if I create an object of the bank account, I'm going to call it account, and with the new keyword, I'm going to initialize this. Now, if I say obj.account and then say I see ID here, and to this ID, I can start assigning values. When I write a statement like this, I'm going to get memory allocated to me from the RAM in one of these two sections, right? Either in the stack or in the data, and in some cases, in both the places. Because bank account is a reference type, it is going to find a location over here, and we have assigned ID equal to 10. When I want to access variables that does not belong to this particular section, we are going to modify. So the static place is wrong. It should be present here. When I put the static keyword over here, the limitation of creating an object to access ID is kind of taken away, and I can access it with the bank account.id equal to 10. When you put the static keyword, the compiler, the C# compiler, knows that this is not a variable that requires an object. This is a variable that can be accessed using uh, the access specifier or the dot notation. Let me go ahead and create another variable in parallel, and I'm going to call it string, and I'm going to call it name. To access name, I'll have to use the object account and the name variable here. I'm going to put my name. Now let's go ahead and build this, and I'm going to remove the .NET 3.1 moniker from here. Let's go ahead and build again. So we get the DLL file. Going to copy this and open it inside the IL spy. Now if I dig deeper, the program file is modified with a private keyword. If you don't specify anything, it is private by default, and it is accessing it this way. But then if I look at the bank account, and if I compare it with the IL with C# code, there will be different fields. So member variables that are going to get accessed, they become part of some other memory location. Give me 1 second. So the ID is under field, and I'm looking for the name parameter. I think for the name parameter, so these two are constructors, and the name itself is defined over here as a property, right? When something goes in as a field, it becomes accessible without an instance. All right, you don't have to create a variable for that, right? So the reason we are creating main as static is because there is nobody who can create instance of main program. The program itself is going to get used by the CLR, and CLR would want to access this main function without creating an instance. And that's why we have to put a static keyword over here. Right. Another thing that I would want to tell you at this point is when you want to define some function on it, say logger. The two parts of a data type, the memory representation and the operations, they are going to have different spots. Now, because operation is going to have code-like statements where you're going to perform operations like A plus B, you're probably going to do some logging, right? These things, they translate to assembly language code. They're going to do special activities over here. They perform some operations. Because these operations or these functions and methods, they are code, a function is going to go and sit inside this code block. All right. And because this is memory structure, they are either going to go to data or they're going to go to the stack segment. Right. The operations are going to get shared across multiple objects. So if I create, say, 3 bank account 1, 2, 3, account 1, 2, 3, they're going to have different memory locations. So account 2 is going to sit here, account 3 probably is going to sit here. But the operation that we have defined on that particular account, they are all going to sit only in the code segment, right? Each function is not going to get a separate copy for each object, right? The copy of these function is present in the code segment, and all the objects, they share the code base in a common way. So there's going to be only one piece of code, which is this binary sequence, and then it is going to figure out at runtime which object is trying to call that function, and for that function, it is going to take an action. All right, so it is 9 on the clock. Let's take a quick 10-minute break, and then we're going to start back at 9:10 again. All right, thank you.